Hey there everyone, welcome. In this series, I am going to teach you C++ for absolute beginners. So if you want to learn C++ and get a sort of a base point, then this is the perfect series for you. But before you start learning C++, you should understand that why exactly are you learning C++. So C++ can be used for a variety of reasons such as game development, desktop development, or even operating system development. But what I'll not recommend C++ for is, for example, web development and machine learning, deep learning, mobile development. So if you are going to do any of these, then don't take C++. If you are going to do mobile development, then take either Java or Kotlin. If you want to do machine learning or data analysis, choose Python. And if you want to do web development, then choose JavaScript. And this is really important, so please take note of that. Now, as you're completely ready to start learning C++, let's just get started. So today we are going to be looking at some basic things in C++. So we are not going to dive into how to actually code in C++ today. We are going to be looking at some of the terms that are used in C++ and some of the things that are used in C++. So firstly, let's understand what exactly is C++. So C++ is a general purpose medium level programming language. Now a medium level, what I mean is that it's high level and low level at the same time, right? So what I mean by that is it can support high level things such as object oriented programming and low level things too such as memory management. So that's why I've called it medium level here. It is used for a vast range of purposes such as desktop development. So one of the things you can use C++ for is desktop development. It's highly performant and thus is used in games. So a lot of games you see today such as Red Dead Redemption 2, Grand Theft Auto 5, even Minecraft Bedrock Edition use C++ because C++ is a very highly performant language. So the predecessor of C++ was C and the predecessor of C was B. So this kind of relation you can say is, for example, there's B here. It's a programming language, or it's not a letter, it's a programming language in this case. And it evolved to C. And then C evolved to C++, which we are going to be learning. Alright? And this point actually says my previous point, right? So C++ can support memory management, which is one of the low level stuff, and OOP or object oriented programming, which is high level. Now let's actually know what is a compiler and what is an interpreter. So a compiler and interpreter do exactly the same thing, but in a different way. So both of these actually take our written code and translate that into machine code so that our computer can understand it. But still, there are a lot of differences between these. C++ is a compiled language, so we are going to be talking about compiler a lot in this series, not about the interpreter. But it's actually really good to understand both of these, so we're going to look at some of the differences. So basically the compiler can translate human readable code into machine code in one go. So it basically takes all of a file and it translates into machine code in one go and generates an exe file. While the interpreter does not do that. It translates the human readable code into machine code line by line. So it's not like in one go. And it does not generate an executable file too, because it's translating it line by line, not the entire program at once. Now in the case of the compiler, the program is slower to start but faster while running. So what I mean by that is when you actually have to start it, then the compiler takes a few seconds to actually compile everything because it basically translates everything you have written. So it takes a few seconds, and then while running it's way faster because while running it does not have to actually translate your program. But for an interpreter, it's a different story. So the program is faster to start but slower while running, which is totally opposite. So interpreter does not really have to do the translation before like running the application, so it just starts, right? But while running, for every like line of code, it has to like translate that line. Every time a line is like you have to execute a line, right? So it has to translate that. So that's why the program is slower while running. Now this one is the advantage of the compiler, so bugs can be identified before running the application. So as it's compiling everything or as it's translating everything, the compiler is basically translating every single line of code at one go. It can actually detect syntax errors or other types of errors which are present in a program before running the application. But for an interpreter, it cannot do that. There are only a limited amount of bugs you can actually identify before the program runs. So yeah, that's a disadvantage for the interpreter. Now C, C++, Java, etc. are all compiled languages, and some of the interpreted languages are Python, QBasic, and JavaScript. Now let's see how does a compiler actually work. Now we have seen in the previous slide what is a compiler and what are its advantages and all, and what are the differences between a compiler and the interpreter. But for C++, we are going to be working with a compiler, so we need to know how does a compiler work. So basically you have your CPP file, and CPP is just one of the extensions for C++. Now you have your CPP file. Now it goes into the compiler and the compilation takes place, and after compiling, the compiler translates or converts your CPP file code and translates into machine code and generates an exe or .out file. So exe for Windows, .out for Mac. Now this is not exactly a very detailed version of it, so compilation also has some steps. It has 6 steps, and I will also leave a link to it in the description down below if you want to see it, but it's not really necessary right now. Now let's actually talk about some syntax stuff. So what exactly is syntax? So if C++ is your first language, then you probably don't know what is a syntax. So syntax is basically a set of rules that defines the basic structure of a language. So for example, you have to create a variable. So you have to create the variable according to the rules of the language, right? You cannot like just say anything, right? So you have to follow a rule, you have to follow a syntax. Every programming language has its own syntax. So Python will have its own syntax, Java will have its own syntax, and C++ will have its own syntax. So blocks of code in C++ are kept inside curly brackets. As you can see, this is a block of code and is kept inside curly braces. Every statement ends with a semicolon. As you can see, this is a statement for actually literally printing hello world to the screen, and we are ending it to semicolon. So don't actually care about much of these if you don't understand them. Let's care about, we are ending it with a semicolon. Now let's actually talk about some things in object-oriented programming. So object-oriented programming, or OOP is short form of object-oriented programming. So basically it deals with classes and objects. Now a class is a user-defined type. It is similar to C's structs. So C has structs and C++ also has structs, but it has classes as well. Now a class is actually made up of data members, which are variables inside a class, and methods, which are functions inside a class. Now if you don't understand much of these, then don't worry. We are going to be looking into object-oriented programming soon. I mean, not very soon, but after we have done the basics, we will be looking into OOP, and that time you will understand everything. Now we know what a class is, so it's a user-defined type. An object is an instance of a class. And to understand it even more, I have a quick little example here. So we have a user class, and it has some data members and some methods. And we have 3 objects, user1, user2 and user3, which are all objects of the class user. So you can say user1 is a user, user2 is a user, and user3 is a user. So that's some things about object-oriented programming. So that was it, an introduction to C++. If you liked the video, then please do leave a like. It really helps out with the YouTube algorithm. And please do subscribe and turn bell notifications on so that you can be the first person to get the notifications for my videos. And now I'll see you in the next one. That was it for this video, and I'm out.